La Nina's last gasp. I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast, the week starting Sunday, June 19th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Looking at significant wave heights for the South Pacific Ocean, we see the beginnings of a new gale southeast of New Zealand. And that's on top of two previous gales, one in the Tasman Sea and one just east of New Zealand. So, an active pattern is underway with swell in the water. Thank goodness. Let's get into the details. As usual, we'll start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they form, help direct their track. We're looking for a trough, that is a push in the jet to the north, just like that right there. What that helps do is create a clockwise flow aloft and down at the ocean surface. And in the southern hemisphere, that's the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. Winds, if they're strong enough over a large enough fetch area aimed at in your direction, generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. So it all starts with a trough, and we have a decent one here with what is this? Oh, we just get that right there. We go 140 knot winds pushing up into the south or into the east west quadrant of this gale. That's giving it all its potential. And also notice that the southern branch of the jet here is impacting the northern branch, providing yet additional 190 knot winds in the north quadrant of whatever gale forms here. That's pretty ripe for storm development. Putting this in motion as we get into Monday, notice the gale continues actually getting broader in coverage and interacting with the northern branch of the jet stream through Monday night and even into Tuesday, and then things start weakening in this all-important west quadrant as you get into Tuesday night and Wednesday. And then things, yes, the trough is still there, but it's very weak, and most of the energy now looks like it's aimed southeast at Antarctica, so that doesn't do a whole lot for us. And then as we get into Thursday and Friday, notice the jet, the southern branch splitting off here, diving south. That's actually what you call a ridge that supports high pressure between the two split jet stream flows, and that pretty much is the end of storm production. We'll roll this out just to make sure, and we're into, there we go, 180 hours out. The ridge holds, but it's not a super strong ridge. It almost looks like another trough, or at least winds in a decent position, are going to start filtering up into the Tasman Sea a week from now, giving us some hope beyond. So let's inspect the effect of jet stream level winds on surface level winds. Surface level pressure and surface level winds here. And sure enough, as expected, there's New Zealand right there. A trough, we know, is developing in this area, and there's a gale with 45, almost a tiny sliver of 50-knot winds starting to push up into its western quadrant, aimed due north. So 30, 35, 40, 45-knot winds, if not more, already developing, probably starting to get some traction on the ocean surface. As we get into almost Monday, we see a little tiny pixel. We'll go back one frame here. Couple of pixels there of even 55-knot winds, and not bad, but mainly 45, 50-knot winds, not over a huge area, but aimed well to the north and positioned pretty far to the north too. The further north the storm goes, the less travel time to Tahiti, Hawaii, and the U.S. West Coast, so the less swell decay there is. A secondary fetch starts developing southeast of New Zealand on Monday with 35 to 40-knot winds. Notice the fetch in the east quadrant pushing due south now, so this is really all that matters. Still 30 to 35 knot winds over a good area as we get into Tuesday morning, building to 40 knots. Not bad at all. Aimed again well to the north. Hawaii's at about 157 west, so right here. So fetch still aimed at the Hawaiian Islands, certainly Tahiti, certainly at the U.S. West Coast. That continues into Wednesday morning until the gale pretty much fades out. After that, we expect to see nothing but high pressure, and we see a little bit of high pressure, but it starts building and filling the bulk of the southwest and central Pacific as we get into Saturday and Sunday, and that is pretty much the end of that, at least for a little while. So we mentioned earlier there were two previous storms, one in the Tasman Sea. Right here you can see we're going back a week, Sunday, June 12th. Swell from this system is hitting Hawaii and sort of trying to reach into California, but it's got to get through all the little islands here. And even for Hawaii, it gets significantly just chopped. The size just gets greater, graded right out by these islands, and California even less. Doubtful, maybe at top spots in Southern California in a day or two there'll be some rideable waves, but not a whole lot. Okay, this was mainly a Fiji and much less a Hawaii event. But as we got into Tuesday, the gale redeveloped, producing, let's see what we got up to here, right about there, 39-foot seas aimed a little bit more east than we'd really like. We want to see it more aimed off to the northeast, but you take anything you can get. Continuing into Tuesday night, 39 feet, then fading from 35 feet on Wednesday, pretty much gone by the time we got into Thursday. Swell from that system also pushing north, expected into Hawaii, earlier part of the work week, and into California, the latter part of the work week. Nothing huge in size, but 2 feet at 16 seconds, 17 seconds, something like that, roughly. Rideable surf for sure. And then, so now we're just going through 2 days ago, Friday and Saturday, and you can see nothing really happened. But starting this morning, that new gale started to develop. Winds started getting traction on the ocean surface, 22, 23-foot seas sort of thing. Nothing huge, but there we go. There's where the core of the winds are, and that is right about now, a little area of 30-foot seas developing. Now notice how tiny this area is. So as we get into Monday morning, 36-foot seas over a tiny little area, but pushing pretty well off to the northeast. Can to 37 feet midday Monday, and then down to 34 feet and fading out. So a small, short little burst of decent winds and seas, but then secondary fetch producing seas in the 22, 24, about maybe 25-foot range, and they're building to 28 feet are expected Tuesday night and into Wednesday. So relative to Hawaii and California, we'll say 14, 15-second period lingering energy off for a good while, and then by Thursday, all this is supposed to fade out. We'll roll it out. Beyond there, nothing is forecast. Looking at winds and wind swell. So the pattern of late has been late season low pressure systems traversing through the Gulf of Alaska, pushing into the Pacific Northwest, even dropping temperatures into the Sierra. I think this morning at one point up over Tioga Pass Road, temperatures at the peak where it intersects near the Tioga Pass Resort, temperatures were 22 degrees this morning, but that's all going to be a distant memory very soon. The low pressure pattern appears to be just wrapping up completely. High pressure taking dominance, and summer is going to officially be here. Now, high pressure in control, 10-30 millibars, generating the usual pressure gradient along the California coast. It's all been southward displaced this summer. Winds 15 to 20 knots on Sunday, building this afternoon to 20-plus knots, and trades solid into Hawaii, about 15 knots. So we get into Monday, the gradient builds a little bit more, 25 knots off of North California, 20 knots, so pretty much a blowout for North and Central California, except the most protected spots. Trades continue for the Hawaiian Islands, producing wind swell. Notice the gradient getting even tighter with 30 to 35 knot winds, but the good news here is it's going to be more normal. Isolated to the Cape Mendocino area, yes, 20-knot winds still pushing down the coast, but as we get into, well, here we go, Tuesday morning, this is the more classic kind of California weather setup. Strong winds off of Cape Mendocino, 30 to 35 knots, but the beginning of this eddy, you see a little bit of low pressure here, and what happens is you end up with south winds along the coast. The good news about that is it stops the upwelling pattern for central and parts of Northern California, allowing water temperatures to perhaps start rising. Also on Tuesday, trades continue for the Hawaiian Islands and wind swell. Tuesday night, more of the same deal. The gradient and the eddy flow get even more established as we get into Wednesday and Wednesday night, but then the gradient starts fading out. As we get into Thursday, yes, still 25 to 30 knot winds. Decent gradient winds along the coast. eddy flow winds. But as we get into Friday or Thursday afternoon, the winds start turning more northwesterly along the coast, light, 5 to 10 knots, something like that. Trades start backing off for Hawaii, too. Notice a little bit of low pressure again trying to get organized in the Gulf of Alaska. We'll see if it actually does anything. Friday, wind swell starts definitely fading, but a light wind pattern continues along the California coast. And Saturday, more of the same. And we get into Sunday, still the same. No wind swell now, just a pure, pretty much clean slate. Light trades for the Hawaiian Islands, no wind swell there either. And then it looks like come early a week from now, another bout of high pressure and probably the northwest wind pattern again setting itself up. We're hoping that it stays isolated to Cape Mendocino and doesn't blow out central and the southern parts of North California. Temperature profile in the Sierra, this is a different sort of chart here, but still the same sort of deal. Elevation on the side here, this is for the Pacific Crest Trail at Tioga Pass Road. Okay, that intersection is about 8,700 feet, and you can see what the temperatures are at various elevations depending on where you are. So that in Yosemite Valley, temperatures in the 50s getting up to, well, near 80 at times depending on the day. And if I can scroll down here, let's see, there we go. You can actually get some dates and times and that sort of thing. Anyway, you see the last little bit of the cold air in the upper levels of, or the higher Sierra, down to about 45 degrees tonight. And then after that, it's warm, warm, and more warm after that. Summer has arrived. All right, let's go take a look long term. What's going on with the Madden Jullian Oscillation and the El Nino Southern Oscillation? As usual, we'll start by looking for signs of the active phase of the MJO, the Madden Jullian Oscillation. This oscillation, there's two phases to it, active and inactive. One is on one side of the planet, the other on the other side of the planet. They rotate around the planet on the equator going from west to east. One on one side, one on the other. They rotate around opposite of each other. The active phase is the one we're interested in. It is effectively a low pressure system. It imparts energy to the jet stream, which then of course feeds the storm track both in the north and southern hemisphere. But it also can dampen trade winds when it's over the West Pacific, and that's a really good thing. What that can do is take warm water that's normally pulled up in the West Pacific and start causing it to move east in what's known as a Kelvin wave, a ball of warm water that travels from the West Pacific to the East Pacific underneath the equator, not on the surface. If you have successive active phases of the MJO, they create successive Kelvin waves, and as the Kelvin waves erupt off of Ecuador, they warm up water temperatures there. If you get successive active phases and Kelvin waves, that can help usher in El Nino, and that really represents a shift in the Walker circulation. So the Walker circulation is a circulation both in the upper and lower levels of the atmosphere. So let's get ourselves oriented here. South America there, the United States, the U.S. West Coast, the equator right there, and it runs right over the equator, Australia, New Guinea, etc. All right, it's would be westerly winds in the upper atmosphere falling south, then tracking westerly down in lower levels of the atmosphere, and then going up. Rising air is low pressure. See the clouds? Take warm water and moisture that shoves it up into the atmosphere. But it is where, and you notice there's multiple cells along the equator. It is where this updraft is most important. When it's here, like in the far West Pacific, if not into the Indian Ocean, that's La Nina. Okay, you have falling air over the far East Pacific, that's high pressure, which is exactly what we've been in. And high pressure means no precipitation, means stronger than normal trades, and you get that cool signature. You can see it off of Peru and Ecuador right here. Now, when you get into El Nino, the opposite happens. The updraft portion of this circulation, which previously was over here, starts shifting to the east. And notice, warm water starts building off of Ecuador and Central America. That's driven by, you see this here, westerly winds. So the active phase of the MJO basically does the same thing. But when you get successive active phases of the MJO, now the question is, Are they creating El Nino, or is it a shift in the Walker circulation that's actually fueling the active phases of the MJO? Or is it that and the warm water and a host of other things all interacting together? And that's really the thing. There's never just one thing. Life is not as simple as if it's just this one thing, that's it. It's everything working together as a system. It is the integration of the atmosphere and the ocean. They say they're coupled when they are in sync. Right now, we are in sync in the La Nina situation, rising air over the Indian Ocean maritime continent and kind of just allowing only easterly winds and upwelling along the Pacific Basin, not doing a whole lot for it. Where we want to get is here with the updraft portion of the Walker circulation, at least in the Central Pacific, if not in the East Pacific. So with that said, let's examine where we're at. All right, data from the TAA buoy array, series of buoys strung across the equator used for monitoring El Nino. We're just looking at the arrows, winds. This is the East Pacific here, West Pacific here, 5-day average winds. In the East Pacific, winds pretty strong. The length of the arrow denotes the strength. Strong out of the east over the East Pacific, strong out of the east over the Central Pacific, and moderate over the West Pacific, the Kelvin wave generation area. Again, here's the equator. Here's the date line. It's this area in the West Pacific we're all interested in because that's where El Nino starts. That's where warm water and Kelvin waves start. So we call it the Kelvin wave generation area. All right, but it's not the actual wind speeds. It's the anomalies, differences from normal for this time of year. So yeah, the winds are pretty strong in the East Pacific, but that's kind of normal. There may be just a hair, notice the little arrows here, just a little bit stronger than normal here. In the Central Pacific, neutral to just slightly out of the east, and pretty much the same thing everywhere. So the MJO, probably not in the active phase, but not in a strong inactive phase either. Let's go see the forecast for the next week. 850 millibar zonal wind anomalies. That's wind up at about 4,200 feet. And is it blowing harder out of the east or out of the west? We don't care about the north-south thing, just the east-west thing. All right, whole planet on one chart. So let's get oriented. The date line runs right up the middle. Far West Pacific, 135 east. East. So right about there. And Kelvin wave generation area ends about 170 west. And Ecuador, something like that's like over at 80. So right about here. But the blues are easterly anomalies. You can see a preponderance of easterly anomalies. There was a Kelvin wave here. Not a Kelvin wave, a active phase of the MJO. The yellows, reds are westerly anomalies. You can see it. It traversed the Pacific from the West Pacific in late May, the whole way over to south of California and out of the Pacific into maybe the second week in June. And then since then, easterly anomalies, and one can presume the inactive phase of the MJO has set up and is supposed to continue. Not particularly strong, not until June 24th, then building a little bit on the date line, but not super impressive. All right, looking 2 weeks out, this is outgoing long wave radiation. Another way, is there more or less cloud cover than normal? The yellows, less cloud cover, more sunlight reflecting off the ocean surface. Outgoing long wave radiation. Okay, radiation reflecting off the Earth, and presumably mainly the ocean. The blues are negative anomalies, more cloud cover, so one can assume wherever the blues is, that's the active phase. Wherever the yellows and oranges are, that's the inactive phase. South America, Central America, Hawaii, New Guinea, Australia, the Philippines, date line right there, equator right there. Inactive phase of the MJ over the West Pacific. This per the statistic model, and that's forecast to go on for pretty much the next 15 days, 5 days per frame. So you go out 0, 5, 10, 15 days. But the inactive phase fading while the active phase builds in the Indian Ocean. Now, if we look at the dynamic model, it says pretty much the same thing. We'll see if we can frame this up. Here we go. Last frame of the statistic model, last frame of the dynamic model. For this kind of analysis, basically the same. So we got to suffer through about 10 days of the inactive phase of the MJO. That said, we are getting storms and gales and surf. So it does not preclude the development of storms, but if we were in the active phase, there would be additional energy to make the storms perhaps stronger than they would have been otherwise. a deeper dive into the statistic model and the dynamic model, phase diagrams. It tells you where exactly the core of the active phase is. The active phase moves from the Indian Ocean to the maritime continent, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. Where the heavy dot is, right there, that's where the active phase is. This is where it has been in the past, I don't know, I think it's 2 months or something like that. But right now, pretty much over Africa. These are the forecast tracks for the next 2 weeks. So moving to the central Indian Ocean, if the dot is inside of this circle, it's super weak. If it's out here on the far edge of the chart, super strong. So a weak active phase over Africa, forecast to get even weaker moving to the Indian Ocean per the statistic model. The dynamic model shows the active phase kind of noodling around and then maybe making it a little bit further to the maritime continent, figure like Bali, something like that, and maybe a hair bit weaker, but still pretty weak and inconsequential. The upper level model showing areas favorable for precipitation and not favorable. One could loosely interpret that to be where the active and inactive phase is. All right, this goes out 40 days. Let's get ourselves oriented. South America, Central America, Philippines, New Guinea, Australia. 0 is the equator. Kelvin wave area, this is the one we're most interested in because when the active phase is over this portion, the West Pacific, that's where it does all its magic in terms of 1, generating Kelvin waves, and 2, imparting energy to the jet stream. Yellows, areas not favorable for precipitation, dry air. Greens, favorable for precipitation. One can assume that's the active phase. So inactive phase over the Kelvin wave generation area today. You can see it slowly moving off, maybe a little second pulse of it. So some inactive phase influence expected through, we'll say, the 4th of July or so. And then you can see the active phase moving from, we think it's over Africa today. Sure enough, this pretty much confirms it. Moving into the West Pacific, the 9th of July, and then making its trek across the Pacific. This would be a big red zone for active phase development, possibly surf development. But we're in this, and we're getting waves, so things might even get better long term, but we're not going to guarantee that. All right, zonal wind anomalies going out a month. All right, whole planet on one chart again. The blues are easterly anomalies, the reds westerly anomalies. The other thing, the solid contours here, that's the active phase of the MJO. You can see that one we talked about, late April, May, in little dots, but you could pretty much connect these 3 patches here and say that was the active phase traversing the Pacific. And you see westerly anomalies just barely traverse the Pacific too. We're still in La Nina, so La Nina favors the inactive phase of the MJO, of course. And now, well, there's your inactive phase, very weak, not even doing anything. But notice, easterly anomalies forecast to build for the next 1-2 weeks on the date line, while westerly anomalies are all holed up over in the Indian Ocean and the maritime continent. And then finally, the 3-month CFS model. Now, the forecast is top, past performance is down on the bottom. What you notice here, and the blues are easterly anomalies, right? The yellows, westerly anomalies. Blues have been focused since February right here on the date line. And notice, just starting today, if not maybe tomorrow, all that is supposed to shift and move more to about 150 west, so a point south of Hawaii, instead of being on the date line. And you notice that westerly anomalies, now if you've been following this for a long time, you notice the models were showing westerly anomalies much stronger, filling the Kelvin wave generation area. There's the date line right there. Now, only making it to about 150 or 160 east, something like that, but still, a good solid patch of westerly anomalies, again focused right at 120 east, but making some eastward progress as compared to the past 2 years. Let's overlay the MJO here and see what's going on. All right, the dotted contour is the inactive phase, the solid contour, the active phase. We are in the inactive phase. You can see it right there. But notice, even for the next 1, 2, almost 3 weeks, some flavor of neutral to light westerly anomalies setting up in the core of the Kelvin wave generation area, 135 east, that's the right along there. That's the far West Pacific, the date line right there. Kelvin wave generation area ends right around there. So it's this box right in here that we're interested in. Then the active phase of the MJO sets up sometime in, we'll say, the third week of July. And after that, it's active phase all the way and westerly anomalies beyond that. Now, that looks interesting. It looks positive. But when we get to the sea surface temperature forecast, this is still suggesting that La Nina clearly in play. In fact, let's overlay the low pass filter, and you can see it here. The dotted contour here, that's the high pressure bias. Just think of it as the La Nina signal. You notice it actually kind of bends backwards a little bit. Not much. We're talking maybe 5 degrees or something. And the low pressure bias, the El Nino indicator, now it builds over the maritime continent with 2 contour lines. Right now, notice the second contour line here faded out a couple of days ago, but it's supposed to be returning. So for right now, holding steady. Longer term, though, we believe this low pressure bias is going to start making inroads into the West Pacific and at least get us back to a neutral pattern. More to follow on that. So we discussed it's the interaction of the ocean and the atmosphere. So we're going to do that inspection now. We're starting down in the ocean, in the depths of the ocean. We're looking at the balance of warm and cold waters. This is where everything in terms of Kelvin waves start, and everything originates from Kelvin waves in terms of the trying to get the Pacific to warm up. It's been quite cold on the equator for 2 years now. All right, so data from the TAO buoy arrays, a series of buoys strung across the equator used for monitoring El Nino. These are the anchor lines on those buoys the whole way across the Pacific. Imagine trying to maintain that mess. Quite a job. The X's are sensors on the anchor lines. When the sensors go out, someone's got to go reel the line up and go fix it and fix the sensors. Anyway, data from the sensors is collected, radioed up or radared up, microwaved up to a central processing facility. They apply quality control checks on it and then also use a model to fill in the gaps. And what you see is 29 degrees centigrade warm water temperatures in the far West Pacific. That's pretty warm. 28 degree isotherm. It's been hanging right about 176 west. I think that's where it was last week. So really no change there. The 26 degree isotherm. It was at 130 last week. It's at 132. So really no change. 24 degree isotherm pushing into Ecuador. So really no change there. But it's not the actual temperatures. It's the anomalies, differences from normal for this time of year. This model shows a very optimistic pattern with 2-3 degree above normal temperatures in the West Pacific traversing. This is what a Kelvin wave looks like the whole way across the Pacific and bound for Ecuador, if not impacting it already. Now we know that to not be completely true. There is another model here. Same data, different model. It shows massive amounts of warm water, a Kelvin wave just pushing, bulldozing off to the east. At the present moment, at about 105 or 110 west, with fingers of it reaching up to the surface at 135 west and about 119 west. Okay, last little bit of cold water, of La Nina's cold water, is sitting right here in the, where is that, about 85 or 90 west, so basically over the Galapagos, and getting pushed to the surface by this bulldozer of warm water. This is key. We got pretty excited about this last week because this bolus of warm water was locked just solid somewhere around 150 west. And then last week, we got clear signs that it was moving, and this week that it's moving even more. It was, I think, maybe just a little finger to 120. Now it's at 110. Seems like in the next 2 weeks or so, this cold water's going to be out of here. Sea level anomalies. This gives us a clue as it's on the surface, but it tells you what's going on under the ocean surface. Use a satellite, measure the height of the sphere of the ocean. Okay, you take out the waves, the wind waves, tides, and is the sphere higher or lower than normal? Cold water at depth contracts. It'll create a divot on the ocean surface, and that divot, when you see it here, and only on the equator, like, okay, let's get ourselves oriented. Chile, Peru, Central America, Hawaii, equator, dateline, New Guinea there. Cold water we know is at, what do we say, 90 west, the last little bit of it. There's the Galapagos right there. That's where it is. -10. This is not temperatures. This is the ocean is 10 centimeters lower than normal, indicating cold water at depth. The ocean, meanwhile, in the West Pacific is 0 to 5 or so centimeters above normal, indicating warm water all in this area. And that's exactly what those other models are showing. Warm water making it to about 110 west. That'd be right about there, okay? And so this sort of correlates in all these different ways of measuring subsurface ocean temperatures, because you don't have a million sensors down there. So it's all modeled, and it's all best guess and you know, physics, and trying to do your best to determine what's going on. But this is another good way to correlate what we saw in the previous data. Upper ocean heat anomalies. So this is sort of a time phase of what's going on. It goes back a year. West Pacific here, East Pacific here. Last summer, yes, you see blues, colder than normal temperatures, 1, 2, 3 pulses of La Nina, if you want to call it that, or the inactive phase of the MJO or whatever, created much upwelling and dropping temperatures in the far East Pacific. Then in December, Christmas, we're talking 6 months ago, Kelvin wave pushed across the Pacific. Warm water, active phase of the MJO, sort of broke up La Nina, but then La Nina returned. Now here we go again. But there seems to be a much broader area, maybe not particularly burning hot, but a broad area of warm water trying to slosh off to the east. Maybe the trades are weakening a bit, and we think that's really what's going on, because there hasn't been a significant Kelvin wave, but what there might be is weakening trade winds, and that certainly would be a sign that La Nina is blowing itself out. Upper ocean heat anomalies. Upper 300 meters of the ocean surface from the area from the dateline to 100 west, so roughly, and this is on the equator, equatorial upper ocean heat anomalies. The volume, so we had a little bit of warm water last summer before La Nina really got itself going. You saw water temperatures just drop and plummet. Then in December, we had that Kelvin wave that we saw made its way across the Pacific. But now the return to the La Nina state this spring, not nearly as impressive in terms of a volume and a momentum perspective. And as of right now, not surface temperatures, this is down in the ocean. Volume of water is pretty much a balance between warm water and cold water. Neutral, not bad. Now you go, wow, that sounds really good. Let's look at the surface temperatures. And this is sea surface temperature anomalies, differences from normal for this time of year. You'd think, well, if there's an equal balance underneath, everything should be neutral. But no, what we see is a clear La Nina signal. South America here, Chile, Peru, Central America, Hawaii there. And it's really the equator that matters. There's the Galapagos right there. You see just the blues, colder than normal temperatures. This ball of cold water right here, that's at 90 west. There's the Galapagos. Remember we saw there the last lingering pocket of cold water subsurface getting squeezed to the surface, then caught by the trades and drifting off to the west. But also notice pockets of warm water. And we think some of this, where is 119? Right there. Where's 135? Somewhere there. These are those two pockets of that Kelvin wave that were supposedly starting to reach the surface. Maybe not exactly as modeled, but there is a string of warm water across the Pacific trying to get a foothold, maybe a little bit early, but it's trying. Sea surface temperature trend for the past 7 days. Well, cooling right in this area. We think that's, again, the Kelvin wave squeezing the last of that cold water to the surface right in this area. A little bit of warming out in here, maybe associated with the Kelvin wave, but probably way too early to say. We suspect, though, give it 3 weeks or so, and you're going to see this starting to warm. I don't think it's going to light up huge because this is not a strong Kelvin wave, but it seems to have a large volume of mildly warm water, just enough to maybe help kick La Nina out the door, maybe. And then the upper level view, again, just zoomed out, you see still piles of cold water. I mean, La Nina, it's a big triangle from Mexico, across the dateline, down to Patagonia, and everything in between, other than this little bit of warming here. But underneath all this, the exact opposite is happening. It's warm water the whole way out to somewhere around here on the equator, north and south of the equator. Massive river of warm water, not blazing hot, but warmish water. And notice all the warmer than normal water here. So if your Walker circulation and your upwelling part is here and the trades are blowing like this, if the Walker circulation starts moving just out to 160 or even 150, you're going to get westerly anomalies blowing through all the maritime continent here, taking that warm water and leaching it out into the West Pacific. And that's going to be enough to get you a Kelvin wave going. And then that pretty much is what kicks La Nina out the door. And just for reference, so they've broken, NOAA has broken the equatorial Pacific into zones. They call them Nino regions. Nino 1.2 is right here. The official El Nino region is from 120 west, 5 degrees north and south of the equator, out to 170 west, so right here. And this is one of the key factors in measuring El Nino is what are the water temperatures doing right in this area here. So sea surface temperatures in the Nino 1.2 area today, let's see if we can slide this over. There you go. Minus 1.42 degrees, so still below normal. You have to be half a degree below normal or above to even be neutral. So we're still in La Nina territory in this region. But in the official El Nino region, the Nino 3.4 region, that area we were showing you before, temperatures up a little bit today. 421 thousandths of a degree below normal, and we've been at the threshold for La Nina or just slightly above it now for about a week and a half. Hooray! A week and a half is certainly not a trend. To be officially out of La Nina, you have to be at this level or above for 5 consecutive months, so we're only a week and a half into that 5-month period. But at least it's a step in the right direction. We've been far colder than this for a very long time. So there's a little bit of a disparity now. These are the official NOAA numbers for where we are. The previous stuff was from tropicaltidbits.com. They do a really good job because they're trying to assimilate real time, day by day. I think it updates 4 times a day what the temperatures are in these different regions, where this updates, I don't know, once a week or something like that. So a little bit different focus, but still you get the sense. So let's start in the Nino 1.2 region. Now this actually shows temperatures falling there, and I don't think that's really the case, but that's what they're showing. In the Nino 3.4 region, the official El Nino region, temperatures are rising, but according to the previous data, they're up at a half a degree. Half a degree is right there. This is only showing about 3/4 of a degree below normal. So I think some of this is lagging data. What we're looking at, the previous data is about as real time as you can get, maybe not as quality controlled checked. So this is your ground truth, but that other is a good indicator, and it's suggesting temperatures rising where they need to be. All right, so what does the atmosphere above the ocean think's going on? Let's summarize real quick. We have no real MJO activity happening right now. We have a broad Kelvin wave pushing subsurface, hidden from view under the ocean, we think. We have cold water upwelling on the surface off of Ecuador and a massive pool of cold water, La Nina-induced cold water, covering the entire equatorial Pacific. The atmosphere above all that cold water, well, typically cold water doesn't support evaporation. We know a little bit about the Walker circulation now, and you know that where you have the updraft in the Walker circulation, you have a lot of precipitation. That is nowhere in the Pacific. It's over the maritime continent right now. So we look at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and the Indian Ocean, Tahiti, clearly in the, we'll call it the Central Pacific. You look at the temperature, and this record goes back 100+ years, ground truth data. And you make a index out of it. If pressure is lower in Tahiti, the index goes negative. If pressure is higher in Tahiti, it goes positive. Today's value 20, that's plus 20.31. So clearly positive, clearly indicative of, well, one, on a daily index, it doesn't mean a whole lot. but you start looking, you go back a month, you see everything here is positive. So at least a dominance of the inactive phase of the MJO. You have a 30-day average here, sort of takes some of the noise out because it does jump around. Today's value 15.55, and it's been, well, it's lower than it's been. It was 18.5, and did we see it there? 19.18 at one point. Now it's rising a little bit, 15.55, still pretty much in La Nina territory, but the 90-day average is more the La Nina indicator, 19.59. I think last year's La Nina were up at 19, but we're still pretty high, just below, where was the peak? I saw it down here somewhere. It's not 16.5, it was like 16.72 or something. I think that's the highest we saw. Still just under that peak, so still clearly on the surface, looking at ocean temperatures, La Nina. Looking at the atmosphere, La Nina. But down below, something is changing for sure. We can graph out the 30-day moving SOI, and that's done here. The downward spikes are the active phase of the MJO. The upward spikes are the inactive phase. You can clearly see since January of 2020, the upward spikes have been dominant, pushing the index positive up to, well, this says nearly 24, a little bit different base here than some of the other data we've been looking at. And we're on this slight downward trend. The question is, we got to get down to here to even be neutral, and down in here to be in El Nino. We have a long ways to go still. The atmosphere does not change instantly. Even if the big Kelvin wave comes and it erupts and blah, 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 it's going to take multiple Kelvin waves warming the entire subsurface Pacific with a steady stream of warm water so that it can move up to the surface, fill the equatorial Pacific with warm water, and then you'll see these numbers starting to fall. You'll see more active phases of the MJO, and then a return to a more normal cycle. So then finally, the forecast from the CFS version 2 model for sea surface temperature anomalies in the Nino 3.4 region, the official El Nino monitoring region. So we are in, where are we? Late June, something like that, somewhere in around here. Temperatures just below half a degree below normal. And the forecast has temperatures in July rising up to above half a degree, like 0.45. Well, I think we're almost there right now, okay? But then notice temperatures falling back down to about 3/4 or 0.8 of a degree below normal in October and November, and then finally breaking the La Nina threshold sometime in December and continuing upward from there. Now, this is raw data. The PDF, and probably not super good, the PDF corrected version seems to be the one that NOAA is more in favor of, and it's showing a similar picture. Temperatures rising to 0.35 of a degree below normal, or maybe 0.4 degrees in July, and then that fall off with temperatures dropping in September, October, and November, and then in December starting to rise, but just hanging right on the threshold here. The strength of that Kelvin wave, what it does, all that sort of thing is still kind of an unknown, though this model seems to do a really good. The title of this video was La Nina's Last Gasp, and we're saying this is the last gasp here because I think it's just going to blow itself out. The point being, sea surface temperatures will find, they're already hovering near neutral or getting close to it, not particularly well balanced, still a lot of cold water, but as that Kelvin wave erupts, it's going to put a significant dent in the atmosphere in terms of pushing it in the right direction, perhaps starting to allow the Walker circulation core, the updraft portion of it, to move into the West Pacific. Once that happens, then you're back into more of a normal phase. So for right now, Tasman sea swell hitting Hawaii, making small fun waves there, and trying to dribble into California. Maybe top spots, Southern California, we'll see a little bit of it. More hope holding out for the New Zealand swell, that arriving in Hawaii the early part of the work week, and into California latter part of the work week. Go to stormsurf.com, check out the quick cast, or look at the detailed analysis. You get all the info you need there for planning your surf. Waves expected in California through the weekend in Hawaii, probably into at least the early part of the weekend. And then another gale is forecast. Well, it's developing right now behind that, southeast of New Zealand. So another pulse of swell, probably a week to 10 days out from there. So even though we are in the inactive phase of the MJO, we're getting surf, and things aren't so bad. And hopefully things will continue to get better. Longer term, yes, supposedly another pulse of La Nina into the fall, and just a weak pulse. And then as we get into winter proper, it looks like water temperatures are going to return to normal or something close to normal. And as we get, so it'll take maybe 2-3 months once the water temperatures get normal for the jet team to respond in kind. But as we get into mid to late February, something like that, we could actually be back in a normal pattern. As we get, right at the end of winter, we might get this taste of, hey, I remember what it's like to surf when there's real waves, and hey, I remember there being rain and snow and all that. But probably until then, there's going to be a lot of doom and gloom on the news about a dry winter and all that. Suspect, though, as we get deeper into winter, that might all change miraculously. We'll see. Fingers crossed. Don't believe a forecast 4 days out, much less 4 or 5 months out. All right, that's it for this week. If you enjoyed the video, give us a thumbs up. We'd appreciate it. If you haven't subscribed, please subscribe. And let's see, what else? Comments, always welcome. You have any questions? We get some good questions there. Just put it on. If you're thinking it, 10 other people are thinking it too. Have the guts, stand up, ask your question. We'll do our best to reply. A lot of educational material can be shared. If you don't want to subscribe, the link to the video will be at the top of every page of the website, stormsurf.com. You can go there and watch the video that way. Thanks for watching. We'll do this again next week. Same time, same channel. Be safe and go surf when you can. Thank you.